Correct. Yes. So, good morning, everyone. Yes. So, what we are talking about is yes. So, in the last class, I said about how to work with this linspace. Okay. And after that, I said what is the difference between the A range and linspace. And after that, I said about one more function called log space. Okay. And after that, I said about how to work with the zeros, zero filled array. And after that, I said about how to create an array with ones. And after that, I create how to create an empty array. But I said, no, it doesn't create an empty array. So what is the meaning of empty here? You are not giving any input. So the input is not given to this function. So return the new array of given shape and type without initializing what here entries. So that is done by using empty. So what will happen? It will create an array with some values. But is it these values are known values or unknown values? Unknown values. These are called unknown values or these are garbage values. So it means you create an array without giving values. You're trying to give the shape. You're trying to give only a shape. You're not giving the values, but you're giving only shape. So using the shape, it will create an array. But these values are not known values. These are what here? Unknown values, right? So after this, you have some more functions of this NumPy array. Some special functions are there related with this NumPy array. So the first function is hmm, so your special arrays are there. In this, I said about zeros and ones, and there is an empty, and one more is a full. Yeah, let me talk about this function called full matrix. So there is one more function, and what is the name of this function is full. Okay, suppose you have some predefined functions. So there is zeros, there is ones. So here you have a functions like zeros and ones. Okay, zeros function is used to create an array filled with zeros. If you want to create an array filled with zeros, if you want to create an array filled with what? Zeros, then you are trying to use a function called zeros. You want to create an array filled with ones, you are using a function called which one? Ones. You want to create an array with uninitialized values, you are using a function called, what is that? Empty. Empty means you are not giving any values, but it takes some garbage values. But you want to create an array filled with your own values. I want to create an array filled with 5. I want to create an array filled with 6. I want to create an array filled with what? 10. So how can I create an array filled with custom values? How can you create an array filled with custom values? So this is zeros function and this is ones function and this is what here? Empty. But I want to create an array filled with my own values. Custom values are user defined values. Then you are using a function called full. Okay, right? Now I want to create an array filled with some fives. Then how can I create an array filled with fives? I should use a function called full. full matrix. Okay. So that is the difference between empty, ones, zeros, and what is that? Full. So it is a predefined function. Hmm. It is a predefined function of NumPy. And this is used to create an array filled with, it is used to create an array filled with custom values. Okay. So it is used to create an array filled with custom values. User defined values are custom values. So that is nothing but you can define fill value. What you can do is you can define the fill value. So this numpy.full function in Python NumPy library is used to create. It is used to create a new array of a specified shape and data type where all elements are initialized to the given fill value. With a given fill value, then what is the syntax? The syntax of this is, okay, you are writing numpy dot, so numpy dot full, and what is the requirement is here shape, and next one is fill value. You have to define the shape, yes. You have to define the shape and you have to define the fill value, and you have to define which one? Data type, fill value and data type. And anyway, you have other optional arguments, that is order. So order is nothing but row major order. So numpy.full, you are using numpy.full, you are using numpy.full, you are trying to define the shape, you are trying to define the fill value. So data type is default float. And what is the order is row major order. If order is C means which order? Row major order, right? Okay, so here I'm writing import numpy as NP, and I'm creating matrix or I'm creating an array, 1D array by saying NP dot array. I'm creating an array, NP dot, what is the name of the function? Full. I'm giving a shape 5 comma 5 comma 10. So this is nothing but which value? Fill value. Means you are creating 1D array filled with what? Tens. You are creating 1D array filled with tens. You have to understand, if I'm writing A2 equal to NP dot zeros, if I'm writing 5 comma, are giving any value or not giving any input? Not giving any input. But it is created an array filled with what? Zeros. If I'm writing A3 equal to NP dot z once, NP dot once, I'm writing 5 comma. Now it means this array is filled with what? Once. This array is created filled with what here? Ones. If you run this, now it is created with ones. So zeros is filled with zeros and ones is filled with ones. But I want to create an array filled with user defined values. I want to create an array filled with user defined values. Then I'm using a function called full. Now you want to create an array with some 10 elements. 1D array with the 10 elements, and I want to fill with some 8. I want to fill with some 8. If I'm trying to print the array is created filled with what here? 8. Array is created filled with 8. Now what is the default type is? That is based on the value. That is based on the value. If I'm writing A5 equal to np dot full, I'm writing here 5. I want to fill with 5 and I give the value as 2.0. If I'm writing 2.0, now this array is filled with 2.0. So it is filling is done based on the value. Suppose if I'm writing A6 equal to np dot full, I want to create an array filled with, filled with some Python or filled with NumPy. So filled with NumPy. Now when I say filled with NumPy, now this array is created with the type of string. Now this array is filled with what here? NumPy. So you can define the shape. A7 equal to np dot full, I'm writing 3 comma 3. There's nothing but 3 rows and 3 columns. And I want to fill with 7. I want to fill with the 7. So 7 is an integer. So it is created a matrix with 3 rows and 3 columns and filled with value. What is the value it is filled with? 7. So if you want to fill with custom values, you are using a function called full. If you want to fill with only zeros, then you are using a function called zeros. If you want to fill with ones, then you are using a function called ones. So this value can be either positive, or this value can be either what? Negative. So I can give -5. 3 comma 2 comma -5. You can say this array is filled with -5. So with how many rows are there? 3 rows. And how many columns here? 2 columns. With the 3 rows and 2 columns, right? So this is a function called full. Yeah, you understood this functions like zeros, ones, empty and full. Zeros, ones, empty and full. Okay, zeros means create an array with 0 values. Ones means create an array with 1 values. And empty means it will create an array with uninitialized values. And full means you are creating an array with custom values or user defined values. Now you have other functions. Now there is a function called np dot. So what is the name of the function is I matrix. So there is a function called np dot I matrix. See, I'm saying now when you are learning NumPy, so NumPy means where you are using NumPy. NumPy is a library, is used in what? I said it is used for mathematical operations. And you are using a NumPy for which one? Image processing. You are using an image processing, and you are using, I said image processing means it comes under what? AI. That is a part of artificial intelligence. And it will work in which one? Maths means which one? Linear algebra. So when you are working with all this, you are trying to use or you are trying to create different types of matrices. You are trying to create a different types of matrices. So that can be either image processing, audio, video processing, artificial intelligence. And when you're working with linear algebra, when you're working with the mathematics, you'll try to create an array with some initialized values. Okay, right? Yes, machine learning, AMS, which consists of machine learning as well as what? Deep learning. Okay, right? Then you have other special functions. So there is other special functions also there. Now these are special arrays and these are creating arrays. And there is a special arrays called identity and diagonal arrays. So you have a different identity and what is that? Diagonal arrays. So what is an identity array? What is an identity array? Identity array or identity matrix. What is the identity matrix? A matrix which is having, what is an identity matrix? You can call this as an identity matrix or you can call it as which one? Diagonal. So what is an identity matrix? Identity matrix is where it organizes elements, where the diagonal elements can be either 1 or it can be what? 0. Diagonal elements will be what? 1. That matrix you can call it as which matrix? Identity matrix. That matrix you can call it as which one? Identity matrix. So if you want to create an identity matrix or diagonal matrix, you are creating this identity matrix or what? Diagonal matrix by using some special functions. And there is a function called I. There is a function called which one? Diagonal. You have a lot of functions, not only 2 functions. I try to explain you more functions. One is a function called np.I. There is one function called there is function called np.identity, and there is one function called np.diagonal. So there is one function called the np.diagonal. Okay, now there are 3 diagonal or identity matrices. There are 3 diagonal or identity matrices. Now you are creating first one. And what is the first one is np.I. np.I. So all diagonal elements will be ones and remaining elements will be 0. So that matrix you call it as which one? Identity matrix. If the diagonal elements are 1 and remaining elements are what? 0. That you can call it as which matrix? Identity matrix. Now using I, you can create which matrix? A diagonal matrix and zeros here. Create a 2D array with ones on a diagonal and zeros what here? Elsewhere. Creates a 2D array with ones on a diagonal and zeros what? Elsewhere. So that matrix you can call it as which one? I matrix. Now this I matrix can be either square or this I matrix can be either what? Rectangular. This I matrix can be either square or this I matrix can be either what? Rectangular. Square means the number of rows and columns will be same. And rectangle means the number of columns will be more and number of rows will be less. That you can call it as which one? Rectangular. So this I matrix can be either square or this I matrix can be either what? Rectangular. And support shifting the diagonal with the k parameter. It means you can shift the diagonal elements by using one parameter called which one? K. You can shift the elements by using one parameter called K. Now, what is the syntax of this I matrix is you are writing np.I and n is nothing but number of elements. N is nothing but number of rows, and m is nothing but number of columns. Now, m is optional, but n is compulsory. If you don't give the m, then what will happen? The number of rows and columns will be same. Number of rows and columns will be what here? Same. If you don't give m is nothing but which value? Number of columns. M is nothing but number of columns. It is optional. If you don't give m, it will take which one as a m? N. It means number of rows and columns will be same. And k is nothing but diagonal position. This is called as diagonal position or diagonal index. And when you're saying diagonal index, by default it will take main diagonal. Main diagonal means where it starts at 0. Okay, if you take this as one square matrix, if you take this as one square matrix, this is having some 3 rows and 3 columns. Okay, what is the main diagonal is 0. 0 means now this index starts at what here? 0. Now this is called as one diagonal or not? Yes. So these values are filled with what here? Ones. This is 1, this is 1 and this is 1. And this diagonal, the diagonal index can be either positive or the diagonal index can be either what? Negative. If the diagonal index is positive, then it is what here? Above. If diagonal index is negative, then it is what here? Below. Suppose if I'm giving a diagonal index, if I'm giving a diagonal index as what? Positive, like 1, I said 1, then the main index is changed from 0 to what here? 1. So here it is filled with what here? Ones, and remaining all are what here? Zeros. If I'm trying to give the diagonal index as negative, so negative means if I give it as -1, suppose if I'm giving it as what here? -1, -1, then this diagonal will be what here? 1, and remaining all will be filled with what? Zeros. So you can change the diagonal position, you can change the diagonal, you can change the diagonal by using one parameter. And what is the parameter you are using? K. But what is the default data type is float. The default data type is a float. Default data type is a float. Okay, right? You understood this is I matrix. So create a 2D array with ones on a diagonal and zeros elsewhere. And can be square or what is it? Rectangle. And support shifting the diagonal with which parameter? K parameter. And what is the syntax of this is np.i, and this n is nothing but number of rows and m is nothing but number of columns. If you don't give m value, the number of rows and columns will be same. The number of columns it takes which one? Number of rows. And what is the main diagonal is 0. What is the main diagonal is 0, and what is the data type is float. Suppose if I'm creating, now this is useful. Again, I'm telling like when you're working with, example is, when you're working with which one? Linear algebra. You're working with which matrices? Identity matrices. In linear algebra, multiplying any matrix by an identity matrix leaves it what here? Unchanged. When you're trying to multiply any matrix with which matrix? Identity matrix. Is it matrix changes or doesn't changes? Doesn't changes. The elements of this matrix will be what? Same. Elements of this matrix will be what? Same. Getting on. This is one example of where it is used. This identity matrix called I or identity or another function, right? Not only that, see, I've just taken this, but it is used in image processing. When you're working with images, even you can use what? Identity matrices, where you don't want transition and other things. You can represent that image. You can multiply that image. You can multiply that image by using which matrix? Identity matrix, right? So a lot of applications of using which matrix? Identity matrix called which one? I. Now you are creating an identity matrix with some 3 rows and 3 columns. So 3 rows and 3 columns means it is which identity matrix? Square. Because the number of rows and columns are what here? Same. So what is the name of the function here? I. What is the name of the function here? I. And here I'm giving only 3. I'm giving only 3. Now 3 means rows or columns? Tell me, 3 means rows or columns? Rows. 3 is a rows. But how many columns it will take? 3 columns. Because I've given only rows. But if we give only rows, the number of columns will be same or not? Yes. This indicates rows as well as what? Columns. Now what is the main diagonal is? What is the main diagonal is? 0. Okay, 0, 1, 2. So the main diagonal is filled with what here? 1. And remaining all are what here? Zeros. Remaining all are zeros. Main diagonal is 1 and remaining all are zeros. Okay, right? So in the same way, I'm writing here, see here, A2. Now you can change it. Means this is a square matrix. Okay, this is a square matrix. I'm writing here 4 rows and how many columns here? 4 columns. Now I define the number of rows and columns. Now you can see it is created with how many rows and how many columns? 4 rows and 4 columns. So always the diagonal matrix is 2D matrix. Yes or no? It should not be 1D matrix. It should be what? 2D matrix with number of rows and columns. It is a 2D array. It is a 2D array which contain number of rows and columns. I'm trying to say 4 comma 4 comma I'm giving a data type by saying np.integer 8. If I'm writing np.integer 8, so what is the type of this array is integer. So is it 1.0 or only one? Only one. Because I change data type from float to what? Integer. Means it is created array with filled with what? Integers. It is created an array filled with what? Integers. Then I'm writing A4 equal to np dot I. Now I'm trying to use a rectangular. I'm saying 4 comma 2. When I'm saying 4 comma 2, 4 comma 2, when I'm saying it as a 4 comma 2, now this is rectangular identity matrix which contain 4 rows and how many columns? 2 columns. Now I try to change it. Now when you're trying to change it, now suppose A5 equal to np dot I. np dot I, if I'm writing 2 comma 4, now 2 is nothing but number of rows and 4 is nothing but number of columns. Number of columns. Here I changed the number of columns. I changed the number of columns. Now in this case, 2 rows are there and how many columns? 4 columns. Now you can see what is the main diagonal is 0. You can see this is 0 and this is a 1. You can see this is 0 and this is a 1. But if you want to change the main diagonal, if you want to change the main diagonal, you are trying to define k value. If you want to define the main diagonal, you try to give the k value. Now 2 comma 4, or I'm saying 4. 4 comma 4 means 4 rows and 4 columns. And I'm writing a k. I'm writing a k equal to 1. If I'm writing a k equal to 1, now diagonal position is shifted. Diagonal position is shifted one position which side? Right side. One position which side? Right side. When you write this, now you can see diagonal position is shifted from 0 to what here? 1. So what is this index is? See here, what is this index? So what is this index is? 0. Now you change the diagonal position from 0 to what? 1. Now this diagonal is filled with what here? 1. This diagonal is filled with what here? 1. In the same way, if I'm writing A7 equal to np dot I, you are writing 4 comma 4 and I'm writing k equal to 2. I'm writing a k equal to 2. Now diagonal position is shifted at which place? Second place. Now you can see this is a main diagonal which is 0 and this is 1 and this is what here? 2. Now this diagonal has become what? 2. Now you can shift diagonal position by using which one? K parameter. You can shift diagonal position by using which parameter? K parameter. If I'm writing A8 equal to np dot, what is the name of the function is I. With 4 comma 4, this diagonal position can be either positive or this position can be what? Negative. So when you're giving negative, it will shift to which diagonal? If it is a negative, it will shift to which diagonal? Below. If it is positive, it will shift to which diagonal? Above. So upper triangle, lower triangle. Okay. So here I'm writing print. So print A8. When I'm writing A8, if I'm writing A8, print A8, np dot I, 4 rows and 4 columns, and k equal to -1. Now when you run this code, now you can see it is shifted which diagonal? Lower diagonal. So you can see 1, 1, and what is that? 1. Now you can define the k value. You can define the k value np dot I. np dot I, I'm writing 4 comma 4. The value of k is -2. The value of k is -2, and you are trying to print A9. So A9 is an array, or it is a matrix which contains 4 rows and 4 columns. What is the main diagonal is -2. What is the main diagonal is -2. Tell me, is it this is clear? This is clear or not? So I'm saying no, even data science people also don't know this, because there are a lot of functions provided by NumPy. There are a lot of functions provided by NumPy. Okay. So is it all the functions are used at the time of working with applications? No. So when it is required, then only use it. But most of the times, the people uses only one function. And what is the name of the function is array. Most of the times you'll be using only one function. And what is the name of this function? Array. But when you require, you can create a different types of matrices by using different types of functions. By using different types of functions. But you are learning all. You are learning all. I'm saying now if you join data science and AI, they teach one number in 2 days, 1 day, 2 days. What they'll teach in 1 day, 2 days? Array creation only. Which array? Only array. Understood? They don't teach how to change the shape, what is broadcasting, how to read. We have seen a lot of ways to read the content of array or not. Yes, they don't teach all those things. But you're learning in detail. It means after learning this, if you move to data science, you can tell more about which one? NumPy. You can teach to the data science faculty. This is NumPy. It is not 2 days. It is number of days it will take to learn NumPy. Understood? Right? Yes. Maximum 3 days or 4 days. Okay, not more than that. Not more than that. Right? Yes. Now I say no, like any matrix, when you multiply with identity matrix, the result is changed or unchanged? Unchanged. The result is not changed. The result is what? Unchanged. Now you can see non-square matrix, which is having 3 rows and 5 columns. I said this example and using the K parameter. Okay, this is also a sheet. I just prepared because it is taking some time to type, right? So I just prepared it. Okay, now. So specifying the data type, and you are trying to specify the data type as what here? Integer. So if you want, I'll copy these examples also. Sorry. So now this is one application where this identity matrix is used. In linear algebra, multiplying any matrix by an identity matrix leaves it what? Unchanged. Okay, for example, you create one array. Suppose you created one array. Now you know the rule for multiplication, right? Okay, so I'm creating an array by saying np dot array with a list 1 comma 2 and 3 comma 4. 1 comma 2, 3 comma 4 and print A. Now this is a matrix with 2 rows and 2 columns. So how many values you stored? 1, 2, 3, 4. Now if you want to create an array using list, if you want to create an array using list, which function are you using? Array. If you want to create a array using a list, use which function? Array. List or tuple. If you want to create an array using sequence of integers, then use which function? I want to create an array using sequence of integers, then use which function? Arrange. If you want to create an array using sequence of integers, then use which function? Arrange. If you want to create an array with evenly distributed, then use which function? Linspace. If you want to create an array with log values, then use which function? Log space. If you want to create an array using existing collection, use what? Array. If you want to create an array using range of values, use which function? Arrange. If you want to create an array with number of elements evenly distributed, then use which function? Linspace. If you want to create an array using logarithmic values, then use which function? Log space. Correct or not? Okay, log space. And there is one more. What is the name of that? Fill functions, special fill functions like zeros. If you want to create an array filled with zeros, then use zeros. If you want to create an array filled with ones, use ones. If you want to create an uninitialized array, use empty. Use what? Empty. If you want to create an array filled with your own values, then use full. Easy. Understood? Easy. But I want to create an array by loading data from file, because data you input you read. External sources will be there, right? External sources will be there. You read the data from where? File. Then how can I read the data from file? That also we'll discuss. The data will be there in file. The image data will be there in file. How can you load the image data? How can you load the image data into NumPy array? But image you enter image data, na? No, image you capture. Image you capture and you load that image into what? NumPy array. Can you save the array to the file? Yes. Can you read the data from file? Yes. So in real time, you'll enter the data, na? No, you don't enter. You read the data from different sources. You read the data from different sources, right? Okay, now I created array. I created array with some 2 rows and 2 columns. You understood how to create array? All of you, yes or no? Huh? So at the end, you should know all the functions. How to create an array, how to read the content of array, how can you perform mathematical operations on array, how to apply some linear algebraic functions on array. We'll be learning all this. Understood? Right? Yes. A. Now this is an array. This is an array contain. So how many rows and how many columns? 2 rows and 2 columns are there. 2 rows and 2 columns. Now I'm creating one identity matrix. So np dot, what is the name of the function? I. So now rule for multiplication. What is the rule? Multiplying rule क्या है? Matrix multiplication rule. Rows should be equal to columns. Right? Number of rows in first matrix should be equal to number of columns in what? Second matrix. Matrix multiplication मालूम है ना ये? मालूम है? But you want where it is used. Okay, right? This is 1, 2. What is this? 3, 4. Now this is a diagonal with 0, 0 na 1, 1, 0, 0, 1, because 2 rows and 2 columns. Now I want to multiply. Then rows with what? Columns. 1 into 1 plus 1 into 1 plus what? 2 into 0. 1 into 0 plus 1 into 0, right? 0 na 1 into 1 na 1 into 1 na 1 into 0 na 1 into 0 plus 2 into 1 na 2 into 1 na yes. Then next is 3 into 1 plus 4 into 0. Next is 3 into 0 plus 4 into 1. So when you multiply with any identity matrix, the result will be same. 1 and this is what? 2 and this is what? 3 and this is what? 4. Understood? Okay, when you multiply any matrix with an identity matrix, the result will be the same. Number of columns of first matrix should be equal to number of columns of second. Columns नहीं होता है यार. Columns है. Columns in first matrix, columns in second matrix. That is a rule. Columns in first matrix should be equal to columns in second. No, rows. That is. You typed my wrong, right? Okay. Okay, right. Now this is having 2 rows and 2 columns. Now C equal to A. How can you multiply? You have an operator. At the rate. At the rate, what is that? B. You have an operator. This is operator. At the rate is which operator? Matrix multiplication operator. If you want to multiply the matrix in other languages, you have to write at least 5 lines of code. You have to take nested for loop. You have to check number of rows in first you have to do all those things and you have to write it manually. But in NumPy, you are writing in how many lines? 1 line. You are writing in 1 line and I'm saying print A comma B comma what is that? C. A comma B comma C. I use a separator as backslash n. Now you can see this is a matrix and this is a B matrix and this is a C matrix. But if you multiply a matrix with any identity matrix, the result will be changed or not changed? Not changed. Understood? Right? So that is where it is used. One application I've taken, but lot of applications are there, but I take an application belongs to which one? Maths. That is linear algebra. So there is one more function is there. And what is the name of the function is np dot identity. np dot identity is another function. np dot identity is another function. np dot identity is a numpy function that creates which matrix here? Square identity matrix. It will create a square identity matrix. A square identity matrix is a 2D matrix where all diagonal elements are 1 and all other elements are what? 0. Now top left to bottom right. Top left to bottom right. So mathematically for 3 by 3 identity matrix will be like this. Okay. Now main diagonal is what? 0. 1, 1, 1 and remaining all are what? Zeros. So even I function is also used for creating which matrix? Identity matrix. But again, there is one more function is there. What is the name of this function is identity. So that is the beauty of Python, right? Python will provide multiple ways, multiple approaches for creating what things. For example, how many ways can you create a list? Tell me, how many ways can you create a list? Is it allows to create a list only in one way or different ways? Different ways. How many ways can you create a list? You can create a list by using what? Square brackets. Okay, this symbol you can use it. You can create a list by using which type? List type. And you can create a list by using comprehension, where you write an expression and for loop like this. So how many ways can you create a list? Three ways. Yes or no? So by using square bracket, by using list type, by using list comprehension, where you write for loop, if expression, everything in one line or not. Yes. So the beauty of Python is it doesn't allow you to do the things in one way. It will provide multiple approaches to do the things. Means all the things what you want it is provided by what? NumPy. You should know it, which function to be used when. Understood? Suppose I want to create a diagonal matrix. If this identity is not there, I is not there, then what I have to do? I have to create using which function? Array function. Yes or no? I have to create it by using array function. So that makes that will take a lot of time or not? Yes. I want to create a 3 by 3 diagonal matrix. Then what will I do? np dot array. I'm using np dot array. I have to write manually 1, comma 0, comma 0. Okay. And then I have to say again 0, comma 0, comma 1, comma what is that? 0. Again I should say 1, comma sorry 0, comma 0, comma 1. 0, comma 0, comma 1. If I'm using array function, then I have to define explicitly values or not? Yes. I have to define the diagonals. If I want to change the diagonal, then I have to change the content of array or not? Yes. So that makes it very complex. To avoid that, it is provided some predefined functions. You can also create an identity matrix by using which function? Array function. But in that case, everything has to be defined by programmer. So that makes it somewhat complex or not? Yes. So to avoid that complexity, you are using some predefined function. Now identity matrix. So mathematically for 3 by 3 identity matrix will be like this. Now there is a number of rows and columns. So what is the syntax? What is the syntax of this is numpy dot identity n is there, data type is there, and n is nothing but number of rows and columns. It must be what? Square. But what is the difference between identity and I function? Now tell me here, you just see and tell me what is the difference between I function and what is it? Another function is identity function. Tell me, I function is used for creating a square matrix. It is used for creating square matrix as well as rectangular. But identity is always used for creating which matrix? Square matrix. I matrix, I mean identity matrix, if you are creating using I, you can change what? K. K is nothing but you can change which positional? Diagonal position. But if it is an identity matrix, you cannot change what? Diagonal position. Now main diagonal is always from 0. Main diagonal is always what? 0. You cannot change the diagonal position. That is where the difference between I and what is that? Identity. Is it clear? These are the differences. Two functions are there, but this is the differences, right? Identity matrix with change columns as well as diagonal positions. We cannot change. We cannot change this. But whereas in I, you can change it. So the matrix shape will be always n into n only. Number of rows and columns will be the same. It must be a square matrix. But when it comes to the I, it can be a square or it can be what? Rectangle. It can be a square or it can be rectangle. Now just to see here. I'm trying to write here A equal to np dot. np dot. See, numpy is like this only. Okay, but if you want to apply some business logic, if you want to do some analysis, data analysis, okay, data analysis, then most of the times you'll go for which one? Pandas. Okay, pandas provide all the functions belongs to data analysis, data predictions, and all the things you can do it by using pandas. But using NumPy also you can do it. So why you are using linear algebra? Why you are using linear algebra? Linear equations, right? Uh, linear equations you write with one variable. You write a linear equation with what? Two variables. Means finding values or not. Yes. Prediction, yes, that can be done by using linear algebra. We'll see some mathematical equations, solving mathematical equations by using linear algebra. We'll see that. But first you learn how to create an array. How to create an array, and what is the name of the function is identity. Now, what is the name of the function is identity. Identity is the name of the function. You define 3. 3 is nothing but number of rows and number of columns. 3 is nothing but number of rows and number of columns. If you run this, how many rows and how many columns? 3 rows and 3 columns. You cannot change the diagonal. In this function, you cannot change the diagonal. Okay. So B equal to NP dot identity. B equal to NP dot identity. I write it 2. Then it will create an identity matrix with how many rows and how many columns? 2 rows and 2 columns. But it is always, it is what here? Squared. So the number of rows and columns are same, right? So creating 3 by 3 identity matrix, an integer identity matrix. If you want to create an identity matrix of integer type, you are using identity 2 comma data type. 2 comma data type np dot integer 16 np dot integer 16. How many bytes? 2 bytes. How many bytes here? 2 bytes. And if I print c, c is nothing but integer. This is integer. This is which type here? Integer. This is integer type. That is 1 0 and 0 and what? 1. Clear? Yes. But it is always square. That is the difference. And there is one more function is there. There is one more function is there. And what is the name of this function is? Yes. The name of this function is np dot diagonal matrix. Is a numpy function that has two main purpose. Okay. One is extract the diagonal elements from 2D matrix. Actually, this is used for diagonal. This function is used for extracting diagonal elements from what? Matrix. If you want to extract the diagonal elements from the matrix, you are using one function called diagonal, and it is also used creating a diagonal matrix from 1D array. If you want to create a diagonal matrix from what? 1D array, or if you want to extract the diagonal elements from what? 2D array. Suppose I have a matrix. For example, I have a matrix where some 3 rows and 3 columns. I have a matrix where 3 rows and 3 columns. 1, 2, 3, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay. Now I want to extract which elements? Diagonal elements. I want to extract which elements? Diagonal elements from what? Matrix. Then how can I extract the diagonal elements from the matrix? I can simply use a function called which one? Diagonal. I can simply use a function called which one? Diagonal. I want to create, there is one 1D array is there. There is 1D array, one dimensional array with some 4 elements. 1, 2, 3, 4. How many elements are there in array? 4 elements. Now I want to convert this array into which array? Diagonal. Then what will I use? I use a function called which one? Diagonal. Correct or not? So it is used. Actually, diagonal uses what? External source. It means it required a source by using which you want to create a diagonal array. Right? So this can be done by using which one? Diagonal function. A diagonal matrix is a square matrix only in which all elements outside the main diagonal are what? Zeros. Main diagonal will be zeros and remaining are the elements whatever you specify. Elements whatever you specify, you can give. What is the syntax is numpy dot diagonal v is there. V is there and the value of K is what? 0. K is nothing but main diagonal. So what is the main diagonal index is? 0. V is nothing but vector. Vector is generally 1D array. But if it is a 2D array, matrix to extract diagonal elements from, it will try to extract what? Diagonal elements when, if the array is what? 2D array. If the array is a 2D array, then it will try to extract which elements? Diagonal elements. Okay, now if it is 1D array, it will create a diagonal matrix. It will create a diagonal matrix with the number of elements, right? So distributed. Now K is nothing but which index? Diagonal index. And default 0 is a main diagonal. Positive K above main diagonal. Negative K below what? Main diagonal. Suppose I have an array. Yes, you understood? Below here, what is this diagonal will do? Extract the diagonal elements and create one identity matrix with those diagonal elements and remaining filled with what? Zeros. Remaining filled with zeros. And if you want to create an identity matrix by using 1D array, then even you can do it by using which one? Diagonal. So I'm writing here A equal to NP dot. What is the name of the function is? Diagonal. What is the name of the function? Diagonal. Now here I create one array otherwise. First I'm creating one array. Now this is my array with 1, 2, 3. It is a square matrix. 1, 2, 3, 4, 5, 6 and 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I print this array, it is created a matrix with number of rows and columns. How many rows and columns are there? 3 rows and 3 columns, right? Now from this, I want to extract which elements? Diagonal elements, and I want to create one identity matrix. Then what I'm doing? I'm saying np dot. What is the name of the function? Diagonal. Name of the function is diagonal, and I try to give the input as what? A. Now tell me, A is which array? 2D array. If the input is given as a 2D array, so if the input is given as a 2D array, if the input is what? 2D array, what will it do? If the input is a 2D array, what will it do? Extract the elements. If the input is given a 2D array, what will happen? It will extract the elements 1, 2, 3. See here 1, 2, 3, 4, 5, 6, 7, 8, 9. What will happen? It extract how many elements? 3 elements. But what this diagonal will do? Will it create one square matrix or not? Yes. With what? Tell me. Main diagonal is what? 1, 5, 9. Remaining all are zeros. Remaining all are zeros. Because how many elements it is read? 3 elements. Now run this code here. Now you can see 159 is there, but this 159 is a single dimensional array or not? Yes. Okay, but output is given B. But if you want to convert this B into which array? If you want to convert this B into which array? Diagonal, np dot diagonal, and I try to give the input as what? B. Now if I say print C, now this is 1D array or 2D array? 1D array. Then it will convert this into which one? Diagonal. 2D array. 2D array with 3 rows and 3 columns. But diagonal returns only diagonal elements as which array? 1D array. But if you want to convert this into identity matrix, then you are trying to give this input as what? Diagonal function. Then it is created one identity matrix with how many rows? 3 rows and 3 columns. 3 rows and 3 columns, and main diagonal is what? 1, 5, 9. You can also create a 1D array. Are you getting or not? Bolo here. So diagonal is used reading diagonal elements. If the input is given which array? It is used for reading diagonal elements if input is given as which array? 2D array. But it will read those diagonal elements and return which array? 1D array. You want to convert that 1D array into identity matrix. Then use again which function? Diagonal. But you are giving which array? 1D array. You have given 1D array, and that 1D array is converted into what? 2D array with main diagonal is what? B. With main diagonal as what? B. And remaining all are what? Zeros. Remaining all are zeros, right? Now D. Now you can create an array by saying np dot array. Now I create 1 comma 2 comma 3 comma 4 comma 5. Now this is single dimensional array or not? Yes. I want to convert this into which matrix? Identity matrix, and I want to use this as which elements? Main diagonal elements. Then what will I do? E equal to np dot array, np dot diagonal. np dot diagonal, and I'm trying to give the input as what? D. So D. Now tell me, it will create a 2D array with how many rows and how many columns? Tell me, it will create a 2D array with how many rows and how many columns? 5 rows and 5 columns. Because the number of elements are how many? 5. It will create a 2D array with 5 rows and 5 columns. Can I change the main diagonal or not? Yes. By giving what? K. I'm saying here K equal to what? 1. Can I write it? Can I write it or not? I said here K equal to 1. K is there or not there? K is there or not there? There. If you run this, you can see 1, 2, 3, 4, 5. But now tell me, is it number of rows and columns are changed or not? Yes. How many rows are there? 1, 2, 3, 4, 5, 6. 6. Because is it diagonal elements are lost or not lost? Not lost. By increasing what? Number of rows. By increasing number of rows and columns. Now, how many rows and how many columns are there? 6 rows and 6 columns. 6 rows and 6 columns. Otherwise, if the same number of rows and columns are there, what will happen? 4 rows and 4 columns means one value is lost or not? Yes. Because of that, automatically increase the number of rows and columns. Now, total number of elements are 5, but you are given main diagonal as what? 1. So, but total number of diagonal elements are what? 5. Then automatically it will change. Now, F equal to NP dot diagonal. Now, I'm using D, comma, K equal to minus 1. If I'm writing a K equal to minus 1, and if I print this F, what will happen? Yes, below diagonal. Now 1, 2, 3, 4, 5. The value of this K means main diagonal can be either positive, this can be either what? Negative. This can be positive or this can be negative. Now these are examples already I put here, right? So in the same way, this is for extracting, and you can extract a diagonal above the main diagonal. So if it is a matrix, now this is a matrix. Now you want to extract the upper diagonal. Means you want to extract 2, 6. Can I extract 2, 6, sir? Yes, here by giving diagonal, main diagonal index. G equal to NP dot diagonal. What is that array? A. A comma K equal to what? 1. So this will extract upper diagonal. Now that is nothing but 2 and 6. If you want to extract the lower diagonal, NP dot, what is this? Diagonal, NP dot diagonal, A comma K equal to minus 1. It will extract what? 4, 8. It will extract the 4, 8. If you are giving input as 2D array, you can see 4 and 8. And using this, can you create an identity matrix? Yes. I equal to NP dot, diagonal input is given H. Input is given H is nothing but it will create a square matrix with 2 rows and 2 columns. And what are the main diagonal elements? 4 and 8. And remaining all are what? Zeros. Understood? You can extract it and you can create it. You can extract it and you can also create it. So you want to create an array. Yeah, you want to create an array by using random values. You want to create an array using what? Random values. Now we have seen how to create an array by using user defined values. By using user defined values, converting list into array. By using which function? Array function. By using array function. And second one is you can create an array filled with what? Zeros. By using zeros function. You can create an array with ones by using ones function. You can create an array with user defined values by using full function. You can create an array. You can create an array uninitialized values by using empty. And you can create an identity matrix by using a function called I. You can create an identity matrix, square identity matrix by using identity. You can read and construct an identity matrix by using which one? Diagonal. Understood all these functions, right? Then next, you can also create an array. You can also create an ND array object. You can also create an ND array object with random samples. You can create an ND array object with some random samples by using which one? Random arrays. So you can create a random arrays by using various functions. You can create a random array by using various functions. So there are some functions like random.random, and there is a function called random.integer, and there is a function called random.randomn, and there is a function called random.choice. So this is nothing but creating. So this is creating, you just take random samples. Randomly you pick up the samples and perform some mathematical operations. So here random arrays are used, arrays or array functions. Random array functions are used to create, an array, to create an array. You are using this to create an array using random values. Using random values. Using, okay, using random values, or you can call it as samples. Random values are samples. So for creating this, so Python or NumPy provides which module? Which module? Random module. For doing this, it is provided one module, and what is the name of the module is random module, and this will provide the functions for creating this random arrays. So we'll do one thing like how to create random arrays. We'll discuss because it's a new topic, right? So we'll discuss about this random arrays, not today, but we'll see tomorrow this, right? So once we learn completing creating of arrays, then we'll see how to perform mathematical operations on this arrays. So at that time, we'll see real-time examples like how you perform mathematical operations on this arrays, right? Thank you. We'll see tomorrow, right? Django will start करेंगे यार चंदन राय. Okay, right? Yeah, we'll see tomorrow. Thank you.